Hey everybody, we are starting Unit 3 of Math 107. The start of Unit 3, this first slideshow is going to be over two sections in the book, 4.1 and 4.2, which are about population, samples and data, and measures of central tendency. So you will see that all of this should be a little familiar to you, and that's why we're smushing those two sections together. All right, so the first section, we're going to construct a frequency distribution, which is the fancy way of saying we're going to organize the data into a table, a frequency table. We're going to build histograms and pie charts, which I think you should have some experience with, but if not, they're not too tricky. And then 4.2, we're going to look at measures of central tendency, which are the mean, median, and mode, and those should be familiar to you. Just a brief overview here. Statistics is the science of collecting, organizing, and summarizing data in such a way that valid conclusions and meaningful predictions can be drawn from them. So this is a very application-based math because our whole purpose of it is to make predictions and conclusions based on the math. So we're going to be dealing with a lot of story problems here, which is cool. We're going to have some like real world applications here because we use statistics very often. Descriptive statistics, sorry, I always struggle with those two words back to back. I don't know why. That is just the collecting, organizing, and summarizing part of the statistics. So that's a little bit more of like the mathy version, I suppose. And then inferential statistics is the more like language part of it. Like what can we write or what can we predict? What can we tell people about our data? So that's the conclusions and meaningful predictions part of that. All right, first, we're going to talk population versus sample. What does that even mean? So the population is just the set of all subjects under study. So a very common study that we do, every 3 to 4 years is figuring out who is going to win a presidential election in the United States. So there's lots of studies that are done, lots of surveys, but the population that we're interested in like accessing are the entire voting population in the United States, which is a huge population. So to help us with all of those studies, like we can't just call up every single voter and get a response. We tried to do that, but it's too big. So when the population is too large, we can break the population into samples. So a sample is any subset of the population. The sample data is collected then and summarized to help us draw conclusions about the population. So here's, kind of a visual of it. Here's our whole population, maybe every, voter in the United States. We're only going to ask these people who they're going to vote for, but we can kind of get into some biases in surveys by how this sample is selected, right? Like if you go to the Democratic convention and you ask everyone there who you're voting for, that's going to be a pretty biased group because all of those people are there to support a Democratic candidate for the most part, right? Whereas if you just randomly select from the population, you will get a better interpretation of the general population for your conclusions. And so we're kind of going to talk about ways that samples can be picked in a good way versus a biased way. Next, we've got frequency distributions. So this is just a fancy way of saying frequency tables. And so this is the first part when we're dealing with any data. We're going to collect all the data, and then we need to organize it. We need to, put it in a way that we can use it efficiently. So steps here to use a frequency table is collect that data, there it is, and then make a table that lists each data point along with the number of times that it occurs, right? That's the frequency. Okay. We could use relative frequency. This is a term that I will use as we kind of get into more advanced frequency tables. And relative frequency just means we take the frequency of a data point, so like how many times did something happen, and then express it as a percent of the total data points. So you're finding the frequency relative to the total number of data points, right? Important thing about relative frequency is that it is a percent. Right, so we're going to create a frequency table for this information here. While bargaining for their new contract, employees of 2-Dye-4 Clothing asked their employers to provide daycare services as an employee benefit. Examining the personnel files of the company's 50 employees, the management recorded the number of children under 6 years old that each employee was caring for. The following results were obtained. So over here, all these numbers in the array are workers and how many children they have under 6. So here's an employee, they have 0 children under 6 years old, so they would need 0 children in the daycare. The next person has 2, next person has 1, 0 again, this person has 3, and so on for 50 employees. So we want to organize this data by creating a frequency table. So I'm going to grab a piece of paper here and show you on our video how we do this. Let's see here. Sorry, getting organized. I should have been more prepared. Sweep out of that. Okay, so bam. First thing we have here, I'm gonna pull up my numbers here again. Okay, so we have to count up, we're gonna count the number of children under 6. This will be part of our table. Number of children, that's what we're talking about. Okay, and then we want to tally up how many we have of each type, and then we want to find that frequency is just writing the number instead of the tally. Let's try to do a way that we can show both of these at once. Okay, so right, try to sneak both of these on at the same time so we can see. Okay, so there's my data over here. So I've got some zeros in there. I'm going to start with the low one, the lowest number of children under 6. That's 0. Okay, so I'm going to count up all the zeros I have. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, I believe. So I should be tallying all that way. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 total. So my frequency is 16. All right, not too shabby. Then people could have 1 child under the age of 6. All right, so I've got 1, 2, 3, 4, 5, 6, 7, 8. I'm just counting up all the ones. 9, 10, 11, 12, 13, 14, 15, 16, 17, 18 ones. There's that one. We could have 2. All right, so 2 children under the age of 6. So 1, 2, 3, 4, 5, 6, 7, 8, 9, I believe. Okay, then we could have, let's see, do I have a 3 in my list? Yep, I see at least one, so I'm gonna write 3 there. Running low on room. Do I have a 4? Yes, and I see a 5 too. Smush this one in there. I know this is so ugly. Okay. Okay, so we've got three now. So I've got 1, 2, 3, 4. Looks like 4 threes. How many 4s? I got 1, 2, I see, and 1, 5. Okay, so this should add to 50 because we had 50 in place. So let me just double check that. Make sure I didn't miss any. Yep, we got all 50. Okay, so I will put that over here. Total, we have 50. Alrighty, and so then this is a frequency table. So this would be, pretty good. I'm going to add one more column though here, and let's talk about relative frequency. right, so this one now is relative frequency, which is our frequency divided by the total number of data points. So for this first one, 16 of the employees out of 50 have no children under the age of 6. So I would do 16 divided by 50. And so that would be 0.32 or 32% for our relative frequency. This is a percent. All right, so 32% of the people don't have any children under the age of 6. All right, for 1, we'd have 18 over 50. Okay, that would be, let's see, 36%. 9 out of 50, 18%. You're just doubling this. That's right. Each number is 2%. So there you go. I don't know if you realize that, but cool patterns with percentages here. We've got 50. This is 8%. Let's see, 2 out of 50 would be 4%. And last one, 1 out of 50 would be 2%. Okay, and so this should add to 100% as well. We could double check that, I suppose. 32 plus 36 plus 18 plus 8 plus 4 plus 2 is 6. Bam, there's 100%. That's good. Okay, so this is a beautiful frequency distribution table that we've just created. So get in the habit of putting all that data in order. And there's a lot of information here that we can go through right away. So like the employers are probably looking at this and thinking, all right, like this would be a vast majority, 68% of our employees would have children under the age of 6. Some of them would have a lot, but only like 6% would have a ton of children in there that would really, need it maybe. I don't know. So they could use all this data to help them decide if they want to go through with that benefit or not. Okay, here we go. Sorry. Okay. Good. Okay, so here is the formal frequency data table. So we did all of this, but that's in there if you want to go through the slides. There you go. All right, so then we could have frequency tables with grouped data. So we want to do this if there's not clear-cut numbers that repeat. So like in the last one, the only numbers that existed were 0, 1, 2, 3, 4, or 5. This one we're all across the board because we're talking about people who are at least 16 years old going to this acting class. So we've got a wide variety of ages here. So we don't want to list out every specific age. We want to group them in a frequency table. All right, so a good protocol to use is group in groups of 4 to 8. And how we can do that is we got to start with the highest number and subtract the lowest number to find our range. So let me look through our list. Let's see, I see a 62. Is that our highest? 61. Yeah, it looks like 62 is our high. So we could do 62 minus our low, which is 16. So we have 46 is our range. Okay, I'm going to move this away so that you guys can see what I just did there. All right, move on to a new frequency table. I did my highest age minus the lowest age. So 46 is what we want. All right, and let's do like 6 groups. So if I divide this by 6, all right, this is basically, we can round this up to 8. So each age group, we're going to count up by 8s. All right, each group. So here's what I mean by that. We're going to say this is the ages. Okay, and let's say, and let's call this X actually. All right, so the first one, we're going to say X is either equal to 16 or, and then we go up by 8 because we're going to have 8 little groups here. Or actually, we're going to have 6 groups counting by 8s to make sure we cover everything. So if I add 8 to this, that would be 24. All right, so that is the distance of my ages here. Right, I'm going to have 6 groups. So 3, 4, 5, 6, and we can do a total, I guess, too. Lovely. Okay, so then the next one. This, now notice I did not include 24 in this one. So my next one, I'm going to start at 24. And those people that are 24 years old are going to be included in this bracket. And then we'll go 8 more, so that'd be 32. So then 32 to 40. I'm counting it by 8s each time. And this would be 40 to 48. And then 48 to 56. 56 to, oops, yeah, that's fine. 64. All right, so that will cover our whole interval, a little bit more, but that is fine. And then this can be like our total column or something like that. Okay, so this looks lovely. Then I need to go back and look at my data so we can make this frequency table. Slide this kind of over again, like I did the last one. This. Okay. Oh, back here. Okay. Oh, dang, it's not letting me. Okay, now I've lost one. Okay, sweet. Okay, so first group, we want to count up or tally all the people that are between the ages of 16 and 24, not including 24. So if I see a 24, then I don't tally here. All right, so let's see. I've got 16, that's a tally. 16 and 24, so 21 would count, right? 18 would count. 22. Another 22. 20. Not 24. There's a 23 that would count. There's an 18 next to it. The bottom row, 19, 20, 23, so 3 more. Okay, so I believe I have a total of 11. So this is the frequency then. Cool. Then I can go to 24 to 32. So I want to count up all of those. Let's see, 1, 2, 3 for 30, and the 25s, 2 25s in there. Okay, 28, 24 would be included in this one. Another 28, and 31 and 29. And then we got a 32. We don't include that in this one. That's just a little high, right? Not including 32. Those are too low. 27 would be in there. 30. 24 again, and that's it. So that would be 13 total. Okay, and so on and so forth. I'm going to kind of fly through this just to save us a little time on this video. Okay, so I'm going to go back and just show you the completed table. Here is that completed table. All right, so it's all about the grouping. So then for the next one, we'd only have 7 people, 3, 2, and 6. We add all these up, or add all of these up, our frequencies, then we have 42 total. And so then we can find our relative frequency. So 26, 11 out of 42, that's our frequency divided by our total. 26% of the people in class are the age 16 to 24. Our biggest group at this acting class are ages 24 to 32. So we can kind of use that to make some conclusions. All right, not very many people showing up from the ages of 48 to 56. So maybe you want to advertise more to those people. Maybe you want to advertise more to this group of people so that, because that seems to be your biggest client base, that kind of thing. Those are some conclusions that you can draw from this information. All right, so here's just a little cheat sheet of how to construct a frequency distribution or a frequency table. So I'm going to just let you guys read that if you ever need it, but that was the end of frequency tables. Now, we can use frequency tables to draw histograms. So when data is grouped for in intervals, like we just did, where we grouped by age, then we can make a bar chart called a histogram that shows how the data is distributed in each interval. All right, so how we do this, we put the class limits on the x-axis. So on that last one, like the ages of the people would go on the x-axis. The y-axis is the frequency, so that's why we have a frequency table. And then the other vertical axis is the percentage of data contained in each interval. So for example, this would be the ages of that acting class. So you can see right here, we had 11 people, ages 16 to 24. So for ages 16, so first of all, x-axis are all of those labels. We're counting by eights. So 16 to 24, 24 to 32, 32 to 40, right? So on and so forth. We had 11 that we counted in this group, so that goes to about 11 here. All right, and then the other thing that we can mark over here, our relative frequency, RF on this axis, was 26. So that's about right in here as well. So we're kind of using both axes to find some information, which is pretty cool. All right, so this is an example of a histogram. You will need to do this on your test. All right, relative frequency versus density. Let's first talk about why this is important. I want to show you part of your textbook. All right, this now is the same information, but let's say we grouped these ages differently and we group them like this, not equally. Okay, so, all right, so let's say that we went from, okay, there. Let's say we considered the ages 15 to 20 and then 20 to 25. So those are all by 5, right? 25 to 30. But then we grouped 30 to 45. Don't know why that would be, but because we're looking at a greater width, this is going to mess with our histogram a little bit. So that's where we need to consider relative frequency a little bit more, right? And here's what this would look like. Ugh, terrible, right? So here's our ages 15 to 20, 20 to 25. And then when we jump to that interval of 30 to 45, it looks like this giant amount of people, right? So this is a way that you're like when you read stuff on Facebook or even like credited sites, they can trick you into thinking that most of the class are like these people 45 to 65 when we know that that's not true. That's actually only like 26% of our population, but it looks huge because when we look at this graph, we look at the area instead of the height, right? That's just something that our brain does. So we want to focus on the density instead of the, I don't know, the width, I guess is what I'm saying, okay? So this is what is gonna lead us into density here. When we talk about this, okay. Relative frequency density. So density is used to determine the concentration of data in a given interval. Okay, so we take the percent of total data and then divide that by the size of the interval. So really this is the relative frequency divided by the size of the interval. All right, so for example, in that last one, the interval from 20 to 25 contained 11 out of the 42 data points. So then our top numbers are frequency divided by the total, so 11 out of 42. That was what we found for relative frequency. Divided by 5 because there's 5 ages in this interval. So our relative frequency density is 0.05 to all that other stuff. Okay, so we can make a whole table out of that. Here's the same information. We have the people ages 5 to 20, 20 to 25, 25 to 30. Okay, those are all with a relative width of 5. And then we jumped 30 to 45. That's a distance of 15. And then 45 to 65, that's a distance of 20. Okay, so we had all this information in that table. 4 people were age 15 to 20, 11 were 20 to 25, 6 were 20 to 30, 11 35 to 45, and then 10, 45 to 65, okay? But now we're gonna add one more thing. We're gonna divide by the relative width. So our density here shows us that for our young people, we have a relative density of 0.02. We have a relative density of 0.05 for the next group, a relative density again of basically 3 for that young group, and then it drops because with the older population, which is more like the first information that we saw at the beginning. Sorry, I didn't mean to click there, but you get the gist. And then we can draw this type of histogram where we have the relative frequency density on the y side. All right, so here's our density here for these age groups, and it looks wider, but now we're showing that they're not super dense, and this gives a better interpretation of the people actually going to class. Like the highest group, the most people attending are in these ages 20 to 25, right? And lower in the older ages. And this now exemplifies that. These are the relative frequencies. 26% of our population is ages 20 to 25. Another 26% of our population is from 30 to 45, but that's such a broad age group that it's spread out farther on our table. All right, so this does a little bit better job showing the types of people that are attending class in a way that our brain understands. All right, so you're going to try to study the output of a machine that fills bags with corn chips. The quality control engineer randomly selected and weighs a sample of 200 bags. The frequency of the distribution below summarizes the data. Construct a histogram for the weights of the bags of corn chips. I would really like for you to pause the video and try this on your own. And then when you come back, we'll kind of click through the slides. All right, you are back. So we've got some intervals here, and I hope you noticed at first that all of these are going up by 0.2. So we have the same width for all of these intervals, which will make this pretty nice. All right, so we can make a little histogram. All right, so for, also calculated the relative frequency. So this is just dividing our 10 divided by our total, which would be 200. So if you added that, that's awesome. So relative frequency, right? We take F divided by our total 200 here. So all of these are just, 36 divided by 200, that'd be 0.018. Wonderful. We don't need to do the extra step of density because that would all be the same 0.02. All right, so then here is a little histogram that we could make. Let's see, here's our relative frequency on this side. Here's our frequency on the other side. So for the ounces that weighed 15.3 to 15.5, only 5% of our bags were kind of shorting people on that. Most of our bags of corn chips had 15.9 to 16.1. So on the bag, you could say, all right, these have 16 ounces of chips, because that's our kind of average. Most of them are in here. Some you get a little extra. You get 16.5 to 16.7, but that's pretty small percent out of the 200 bags. All right, so if you did not get this, please correct your histogram, but I'm going to move forward. All right, use when we have categorical data, sorry, words are hard, we use pie charts. All right, so pie charts are a little bit different because we don't have numbers, we have categories that we're talking about. So for example, we're going to do a assignment together here. We've got different types of degrees and the number of each type of degree conferred in the United States during 2006 to 2007's academic year, and we're going to construct a pie chart for this. All right, so I'm going to, oops, not here. Okay, here is this. All right, here's my table. So we have 728 people have an associate's degree, and this is in thousands actually, so 728,000 people. 1,524,000 people have a bachelor's and then master's and a doctorate. So to do this, we first need to calculate the relative frequency, which is our amount that we're concerned with divided by the total. So I'm going to do that first. All right, so 728 divided by 2,981. This is 0.249. I'll go 3 spots on all of these, which is fine. Then the next one, I'd have 1,524 divided by the same amount, the total. So this is 0.522. 605 divided by 5, about 20%. And last one, right, so 0.209. All right, so we can add these up. It should be close to 100%. That would be bad. Yeah, pretty close to 100%. So our sum there, we'll just round off to 1. Wonderful. Okay, so then for a pie chart, we need to convert this into degrees. All right, so we have like percentages per se, but we've got a circle. So how do we convert from the degrees around a circle to percentage? Well, we would multiply our decimal times 360. So here I go. This is 0.249 times 360 degrees. Times 360. All right, so this is going to be 89.64 degrees-ish. All right, I'm just going to kind of fly through this just for the sake of time. But we're just multiplying by 360. Next one would be 188.28 degrees. Then 74.52 degrees. And then 7.56 degrees. All right, so all of those times 360. So now we're going to use a protractor. Okay, how I like to do this is I like to draw a line as close to the center as I can get, like right through the middle. So I'm going to say this is the middle right here. Bam. All right, so my first group, I'm going to say I'm going to do this 89 degrees right here. So I line up my 0. Here, that's fine. Okay, and I want to go to, so this would be 0 degrees. Oh, sorry, there's a map. I got to go to 89. So 89 degrees is like basically right out here. So I can put a little dot out there. This is not perfect science because I've got a half sheet of paper. But make those dots then. All right, so this is almost 90 degrees. These are the people that got an associate's. Okay, then we've got a bachelor's, which is, I'll go from this line now. I'll line it up. And I need 188 degrees. So here's 180 from this. I'm going to line to that. Okay. And then I need to go 8 more degrees from there. Right there. Okay, so this is all, this whole section right here, I'm going to make this bigger, is the bachelor's. All right, then the master's is only 74. So here, line that up to this new line. 74, here's 70. 1, 2, 3, 4. Put a dot there, and we can draw a line out to this. Okay, and then the last one would be our doctorate. So this is doctorate. This is master's. Okay, so that is how we can make a pie chart from an information or from data that has categories in it. I'm going to stop the video here because that is the end of 4.1, and then in the next video we can get into measures of central tendency.